Am I audible? Hello. Am I audible to you? Hello. 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 Am I audible?
Yes, sir.
Yeah. We will start now. Uh, Yesterday we have seen all these, single station, then double station, and then number of impression. Then we have also seen the where the article is blown from the top, from the bottom. If the intermittent process is there, then I told you we are using this one, bottom uh, bottom blowing, right? Right. This is the bottom blowing intermittent process and other process. This is the top blowing and the side blowing is possible. Then afterward, we have also seen the thin article and the large article, how we can manufacture by the extrusion blow molding process. The intermittent process also we have seen yesterday. There are two types, a reciprocating screw type system and the accumulator system. This also we have completed yesterday. The components in the blow molding also we have the basic process we have completed. This detail also we have completed this also. Then stages in the extrusion blow molding process we have seen, uh, right. We are you are creating a Parisian. Then here, yes, it's a blow mode part. The Parisian is shifted to the blow mode. Then afterward, it is a get that blowing and the ejection of the article. Whereas there is only 5 steps are there. We have seen this yesterday, right? Then afterward, we have also this extrusion blow molding process. This electrical heaters are there, extrusion heaters are there. Is a die, right? This is a mode opening. Parison is entering into the mode, right? We have seen all these. These are the pattern here. This is a mode here. This is a cooling line here. Water cooling lines provided. Okay. Now, just you go through this, the video. I have one video here so that you will get a more clarity on this. Whatever we have completed, that is, I try to show you, in the video form. See now, the 4 Parisian, we have seen this within a one shot, you'll get a 8, the bottles. This is there are, see, this is a die here, 1, 2, 3, 4, 5. See, there are 5 Parisian. See, there are 5 Parisian. This is a 5 blowing, system. That is a one die and 5 blowing station. See here, there's also a blowing station here. There are 2 blowing station. See how it is a get. Yesterday I have seen you. Yesterday I have seen you this, with a simple diagram, right? At every cycle you are getting how many bottle? 10 bottle, five bottle in each cycle, but per cycle you get a 10 bottles. See the production, very fast production. See, there are, multiple work is going on. There are 2 machine. One machine is giving the bottle for the coconut oil, and the second machine is giving a uh, the bottle drinking water. See here the Parisian. How many Parisian are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 bottles. See, now they are going to blowing station. This is a Parisian. It is called as a hot molten tube. It is called as a Parisian. And there are 12. There are 12 die are there, see. And that equally giving a parison a specific length, right? This is called the extrusion blowing, continuous extrusion blowing, continuous extrusion blowing system or process. See now, this is a extruding here and it is here. They are get, you know, uh, blowing station. Very simple process. The mode is a cooled one, right? The water is circulated inside. Any doubt here, friend? Any doubt? Within a one cycle, you are
No,
getting
sir.
a 10 bottle here, friend. Within a one cycle. Cycle time is very less. You can see immediately they are blowing
How much
there.
cycle time it will they are
Just
using?
just that 1 minute, not 1 minute also. It is a fraction of 1 minute.
Okay, sir.
Yeah, you will get a 10 bottle within a fraction of 1 minute, friend. It's a conveyor belt. There are two machines are there. One is manufacturing the coconut oil bottles and the other is bistouri bottles or maybe the drinking water bottles. See now this side, one die having a 12, that uh, extrusion systems and other die having a 5 uh, parison, that is 5 parison, that is a hot molten tube is extruded. See now here are 12. See down is a pinch off is there. See the mold, how they are operating. This is the blowing lines are there. There are 12 blowing lines. There are two blowing station, right? At the left and at the right. And middle is extrusion. This is all a conveyor system. It is a automation is there, friend. Completely automation. See now, instead of blue, now they have used the red, orange one, Parisian. And afterwards, there is a finishing and all these things take place. See now here, the big Parisian, a single Parisian. When it is a specific length, you look at a large article here. A basic principle. Mode is open, parison is created in between the two half of the mode here, friend, and it have a sufficient length, then immediately it will get get cut by the cutter is there. Now see, this cutter is there, it has at the top here. See here, it will cut immediately this thing, the parison. And again you will get a, see now how it is, see the mode here with the handle. All drums are with the handle. This is the unique we have seen yesterday about this, right? See again, this is extrusion blowing, blow molding. We have seen all the possibility of blowing, or possibility means variants. We have seen all variants, right? Top blowing, bottom blowing, side blowing, how the parison is created, how the air is inserted, and how the parison will take the shape of the cavity of the blowing mold. There are two type of mold, right? But here in the extrusion, there is only one type of mold. Remember this thing. Now, advantages, it is a process for the producing a container and the hollow parts prepared for the molding high volume containers. Now, you have seen just now the what are drawbacks? Drawbacks are uneven. Drawbacks are uneven wall thickness, components are produced and it's difficult to achieve close dimensional tolerance. Relatively low accuracy of surface finishing is achieved. Yes, these are the drawbacks generally. But these drawbacks are a minor. They are not, that on a major level. And that's why all the bottles are accepted here. We have seen this yesterday only. Advantage, low tool cost, die cost, fast production, ability to more complex part also, and limited to hollow parts, low strength. Now, what are the application of extrusion blowing, blow molding part spray for packaging of for milk, fluids, medicines, cosmetics? Just we have seen the video also. Automotive fuel tanks, even Activa tank, car tank, also manufactured by the extrusion blow molding process. Oil bottles, air ducts, set bags, seat bags. Then consumer product like toys, houseware, sports goods, etc. Now, friend, even the sanitary items, sanitary, you have seen a flush tank, right? In the flush tank, that there is a one ball, right? That is made up from the polypropylene, and when the flush get filled, at that time it will come up, float on the flush tank. This is also made from the a blowing process. Then drums for the chemical industries, below shapes, shields, and double wall carrying cases. These all are made from the a blowing extrusion process. Now, injection blowing, blow molding, we have also seen yesterday some part. Again, there are some slides I'm showing you now. The first here, a single stage process. You have to prepare the preforma, right? There are two type of mode, preforma mode and the blowing mode in this case. Then the blowing station, the preformer is passed to the hollow cooled blow mode. Compressor is blown there into the preformer and it will take the shape of the mold. The rejection, the blow formed a polymer is allowed to cool, then removed from the mold, cleaning and testing are carried out. What are this injection blow molding process generally used for the material like PET, right? PET jars we are manufacturing large quantity hollow articles we can manufacture from this injection blow molding process. What are the main steps in the injection blow molding process? First, we have to hit the barrel and screw assembly, made the polymer mass. Then it is injected through the heated cavity and core pins where preform forms. Then preforma pass to the hollow chilled mode. The compressor here is blown here and a core rod into the preform. The ejection. The final product is cooled, ejected from the blow mode and stripped off the core rod. This is a very simple process, friend. What are the advantages of injection blow molding? Is produce an injection mold, make for the accuracy, eliminate weld lines. Disadvantage, small capacity. See now, this is the injection blow molding. See now here, the stick is there. On the sticks, we are taking a shot here. This is the first step. Okay, this is the first step. Now we are injecting the material from this side. See now, the second diagram, the black one showing the article. but it is a molten mass. It is in made form. Okay, it is just extruded on the blow stick. This is a blow stick. Now the mode is open here. The now this is called the preforma. Therefore, the first step is to form the preforma. See now here. Here preforma is made by this 1, 2, and third step. Okay, this is just injection molding system is there. Okay, now this preforma is shifted to the blow mode. See now the size of this mode is higher than this. Okay, now this type of a preforma is shifted to here now. In between, you have to give some conditioning to this preforma. That conditioner we will see in the video also, and I will show you afterwards in the next slides. Now, see here is a blow pin. That blow pin will blow the article. This preforma is get blown here, and this preforma will take the shape of this mold, big mold, and hence it is called as a blow mold. This is called as a preforma mode. There are two modes, preforma mode and the blow mode. Now see, here is the blowing take place. This preforma will take the shape of the blow mode inside. Afterwards, due to this compressor here, after this, see now, mode is open and the article is removed. Strip out that article from this stick at the top. See now, if the threads are there, you will get everything, friend. Okay. Now, we are shifting now. We have seen the extrusion blow molding and the second is injection blow molding. Now, friend, this is a basic injection blow molding and the extrusion blow molding. Now, we are shifting to the stretch blow molding, the third type. Right, third type we are now shifting. Any question till now, friend? Any question? Hello, any question here, friend? Now we are shifting to the stretch blow molding. Now, what is meant by stretch blow molding? Why it is a stretch blow molding? Article is stretch blow molded. Right, stretch means you are there are two type of orientation take place. One is a vertical, other is a horizontal, and therefore the preforma or maybe parison, it gets axially oriented and the laterally also oriented, and therefore it is called as a biaxial orientation. The stretch, to do the stretch. Now, why the stretching is used here, friend? Can anybody tell me why the stretching we are doing? Why we are stretching the article, blow molded article? Hello, am I audible
For
to you? Follow.
it's for checking the elevation that elasticity of that article, that it should not be breakable like that.
Okay. Correct. See, the Bisleri bottle. It is a stretch bottle, right? Stretch bottle. If you see now, Bisleri bottle is a very large volume. 1 liter water we are keeping inside. And see now, the bottle is at the neck. There is a thicker. At the middle, there is a thinner. And at the bottom, again thicker, right? Thick, thin, thick, right? Why this? Why this happen? This is due to the stretch blow molding. We are doing the stretch blow molding, and the stretch blow molding benefits are that better strength. We are getting a better strength. We are getting a better clarity. Clarity means barrier property, right? Barrier property, right? All the chains are get elongated in the direction of force, and therefore chains are oriented, and therefore you are getting a bit better clarity, right? Better strength, right? Therefore, barrier property will increase due to the orientation of the polymer. Then increase the impact strength. आपका बॉटल गिर भी गया तो टूटेगा नहीं. You maybe have seen the Bisleri bottle, water bottle. If you drop from the height, maybe 1 meter or 2 meter, nothing will happen because of the bottom is thicker, the middle is thinner, and again next section and shoulder of that bottle is again thicker. Okay. Now, improved gas and water vapor barrier. I told you barrier properties. Water, vapors, and gas. These are the two things they cannot go out, friend. Okay. And hence, this is a very good process to manufacture the water, bottle, or maybe this we are drinking the soda, right? Or maybe Coca-Cola. We can, keep in the bottle because the gas cannot come out from the plastics. Second thing, that Coca-Cola, it also never come out through that PET bottle, right? So, friend, this is a, gas and liquid. We can stop there. And these are called as a barrier property. Gas is a barrier property. Gas cannot pass. Then liquid cannot pass. Okay. Now reduce the creep. So even that creep means, if you can say here the reduce the weight also, because you are giving a orientation, and definitely you can reduce the weight of that bottle frame, right? By stretching the bottle, we reduce the weight. Therefore, there are a lot of advantages and save the material. You can save the material yourself also, frame. By extra orientation, you can save the material. Okay, and therefore it is economical one. Now, types of stretching, blow molding. There are injection stretch blow molding and the extrusion stretch blow molding. We are going to cover these two today. And then tomorrow we will see the a calendaring plant, right? How the calendaring plant and what are their applications, how it work, the design of the, and what are the faults in that. We will going to see tomorrow about the blow molding, right? No, calendaring unit. Now see here, extrusion stretch blow molding and injection stretch blow molding. Now extrusion stretch blow molding generally used for PVC and PET. Okay, PVC and PET, we are using the extrusion blow molding, and injection blow molding we are using for the only the PET. Majority PET are manufactured by the injection stretch blow molding. Remember this thing. And extrusion for both PVC and PET. Now, see the process. See, extruding a parison, yes, you have to first create the parison. Second, converting the parison into the preforma. Yes, you have to create the preform of the parison. Then, blowing and stretching the preforma in the final blow mode. The blow mode is the final. In that, we are doing the blowing of this preforma. Very simple stage. There are only 3 simple stages. Okay. Now, injection stretch blow molding. I told you, suitable for the PET. All PET bottle can be manufactured by the injection stretch blow molding. Injection, injecting a preform, reheating the preform if necessary. See, generally what happens, there are 2 type of process. One is direct heating and direct manufacturing. There's no treatment of the, the conditioning to the preform. And there are some, suppose आपने preform बनाया आज, right? Maybe you manufacture a 1000 preform today. Now you cannot, blow that preform. That's how, if you're getting an order after 1 month, that preform again you can use for the stretch extrusion blow molding purpose. Therefore, again, you have to heat that. For example, you take one example, polyethylene terephthalate, PET. Today, you have made a 90,000 preform of the PET. And now you are getting the order in the next month for the PET bottle of 1 liter. You already have a preform with you, right? You have that preform, again you have to reheat that. Reheat up to the what temperature? Only 100 degrees Celsius. 100 degrees Celsius. Because your preforma is a low pressure made. It is a completely amorphous in nature. right? And therefore, just you have to heat that up to 100 degrees Celsius. And this preformer, again, you have to pass where you have to pass in the blow mode. After that, just take the telescopic pin will just elongate that, and immediately the air will be inflected inside the that preform, and preform will take the shape of the blow mode. It's a very simple process, friend. Therefore, injecting a preform, reheating the preform if necessary. Generally, many times you are getting the bottle order, you just making a preform, and immediately you are just inline only. Inline, not necessary to store that preform. Inline process. If you do this inline process, then immediately what happen? You can make a preform, and immediately you have to blow mold, right? That therefore preforma and blow molding is a inline process. Now blowing and stretching of the preforma in the final blow mold is also done. Therefore, there are two routes. One is first prepare the preforma, wait for 1 month, or it is a direct the inline process. Now see here, stretch blow molding, injection stretch blow molding. See now here, friend, you see injection stage blow molding process, preforma are heated, see, by IR, infrared heaters. See now, it is a 1 month. They have put the complete 1 month or maybe 2 month, 3 month. ये preforma ऐसा बना, this type of preforma you have to made and store in one place for 2 month, 3 month. And when the order comes of such a bottle, that time you use this preforma. That time what you have to do? You have to first heat this at 100 degrees Celsius, because this is a amorphous in nature, and this preforma it is a no crystalline nature, a complete amorphous nature, and therefore easily elongate this thing. And just you when you made this pet preforma, that time the temperature of polyethylene terephthalate it may be 280 to 70 degrees Celsius, 280 to 270 degrees Celsius. Now, at that temp, and very low pressure. Like therefore, preforma made by very low pressure and high temperature, 280 degrees Celsius. Then this preforma, now you are using after 2-3 months. Then again you have to reheat there. How much heat you have to supply here? How many? See, here you can use 100 degrees temperature. Okay, 100 degree after 2 months. If you heat it, put the 100-degree temperature, reheat it, and again go to the blow mode. You have to shift to the blow mode. Again here compress here, and the blow stick will be act here. And see now you will get here article like this. Are you getting, friend? Hello.
Yes, sir.
Therefore, you have to reheat this. After 2 months, 3 months, you can, but you have to prepare this first by injection molding process. Very simple thing. Nothing is there. Now you will get more idea by this video. You can go through these videos so that you will get a more clarity what I am talking with you now. separate. Now you have seen here the stretch injection blow molding process, right? Now here, if you see here, there are, see, it is a pet. Polyethylene tertiary material is there. Is a conveyor barrel is there. Feed zone, compression zone, metering zone, and then see how it is passing into the mode. Now here, if you see here, see this is a the injection line. Okay, you are just making an injection here, and is on the this blow stick that get injected, right? There are threads. There are threads are here, thread here, also thread. Now the material get injected here. This is the injection mode. 1, 2, 3, 4. They are the injection mode. Okay. Now if you see now here again, the material gets injected here and preformas are manufactured. Okay. See now here, the material is passing through the barrel. See, now the material is injected here. Okay. Now after that, this is going to the a blowing station. This is a blowing station here. See, this is a blow mode. Blow mode. Now see the pin is get first elongate that preforma and the compressor air will pass here. They get then they cooled that bottle. And now see now it will get dropped here. Yes. See here per pet, we are using 280 temperature frame, right? For the process, injection molding process. Okay, 280 degrees Celsius. Here temperature is 280 degrees Celsius temperature. Okay. Now this hot Parisian shifted. Yes. See now, this is the optimum of the profile. And now here blowing it take place. See now, the condensing, correct. Heat conduction. Now, that's very important. And now, see now here, it's going to the blowing station and get blown here. Yes. Now the stretching. See here, telescopic stretching rods are there. And immediately you have to pass the compress here. This mode are cool. Injection stretch blow. Number of bottles you can manufacture. see the another video, friend, so that you will get a more clarity on this. Step 1, step 4, injection stress blow molding process. See now here, injection will take place. See now, the red part is preforma manufacturing. Okay. Now it is going for conditioning here, conditioning. Okay. After conditioning, now it is going to the next stage, blowing station. See now it go to the blowing station. This is a blowing station. Okay. See the blow modes are there. The ejector pin, that telescopic pin will elongate that preforma, and you have to pass the air. Then get blown and cool immediately. And you have to eject the bottles. Very simple process. Any question here, friend? Any question in this case? Hello?
No, sir.
It's a very simple process, friend. You are making the 4 bottle immediately by using the injection stretch blow molding process. Why we are stretching? Because of the we are getting a good strength, good volume, barrier properties, reduce the material, light, high volume and lightweight of the sample. Okay, these are the advantages of the stretch blow molding. इसलिए तो हम लोग stretch करते हैं. And you can open also your a industry by using the blow molding. This is SB company, friend. They are manufacturing these machines. Okay, SB international company it is an international company, SB, and it is at Bombay also. There are a number of plants are there, and they are giving this machine. You can also buy a machine from them, and you can some other people are making a bottle, but you can make the other product, maybe fuel tank, maybe you can manufacture the flush, flush tank, that ball. There are many hidden application, friend. Okay, not only bottle, but also you can see if you buy that flush tank, that ball inside that flush tank. If you open the flush tank, you can see there's a one ball is there. That ball manufacturing cost is hardly 3 to 4 rupees, but they are charging the 50 rupees, 60 rupees in the market. Okay, and there are a lot of margin is there. You can open your own industry also and just supply to the plus tank manufacturer. Okay. Now, stretch blow molding product and applications. Carbonated and soft drinks bottles, cooking oil containers, agrochemical containers, health and oral hygiene product, bathroom and the toiletry products. I told you number of products, even medical also, medicinal bottles also you can manufacture by this stretch blow molding because the barrier properties are very good, right? Cooking oil containers that I told you just now, then all Coca-Cola bottles, soda bottles, right? Even thumbs up bottles, all the soft drink and hot drink also. You can manufacture bottles by this using the stretch blow molding process. Okay. Any difficulty here, friend? Hello, any difficulty here?
No, sir.
No, we'll go ahead now. See, if you see this video again, I have one video here. Then you will again get some good knowledge before starting the extrusion blow molding. Now we have seen the injection stretch blow molding. Now we can see in extrusion stretch blow molding now. before this, you see this video, then you will get the complete idea. This is also just stretch blow molding. See now one by one stage. See now here. See, Fred, now you have seen here how I told you the how the preforma are manufactured. First, preforma. You have seen here a number of preforma, they are manufactured by the injection molding machine, right? There may be a 30, 40 preforma they are manufacturing there, and that preforma they are storing, right? And they are also shifting the other automatic machine preforma. You have seen now. Even you can manufacture such a preforma and you can sell to the blow industry, right? Now again that all preforma they collected together and that preforma are shifted to the same in the same plant, right? And there all the preforma are get serially arranged by the machine and they are heated there for the that is called as a just preheating by the IR heating, infrared heatings, and that what is the temperature of that? 100 degrees Celsius. And that after that, preforma, you have to shift to the a blow molding unit, right? A blow molding mode where all the preforma are get shifted, transferred there, and the process of stretching the preforma, and after stretching, immediately they are blowing the uh, the preforma, and in such a way you can manufacture a 1 liter bottle or 2 liter bottle by this process, injection stretch blow molding process. Therefore, there are two type of variants in injection blow molding process. One is by accumulator, one is by uh, to prepare the preformer first and wait for maybe 1 month, 2 months, and again that preformer you have to take in the blow mode after IR heating, then take the blowing of that preformer, and you can create the article. The second thing, second variant is like that, inline. Just make the preformer and immediately you skip to the blow mode. That machine also you have seen now. Therefore, there are two type of variants in a injection stretch blow molding process, right? We have seen now 2 3 videos on that. Okay. And if now I told you the advantages of a stretch blow molding is that, what are the advantages? You can reduce the weight of the article. You can have a barrier property will enhance the tensile strength. Strength of the bottle will increase. Bottom strength also increase, right? And you are getting a neck uh, precision type of article. Such a type of, you can save the cost of the material because lightweight article and high volume you are getting by using the blow molding machine and blow molding mold, friend. Therefore, this is a very good, you know, machine which will give you the higher volume uh, articles. I told you there are a number of applications of this stretch blow molding process. Here, I a bigger article also you can manufacture with this, having a barrier properties and dimensional stability. Okay. Now we'll just proceed on the next, video. 1 minute. We have already seen this video now. We will shift to the other, uh, injection stretch blow molding. Now we have seen the video of this, right? Now, what are the you have seen in the video? That's how I am going to talk here. The plastic is first molded into a preformer by injection molding process. Simple things. After that, the preformer are heated and blown in a high temperature pressure ratio. Yes, that also we have seen in the video. The heated preformer is always stressed with a core. Core means that blow stick, right? You have seen that blow stick there. The stick is get elongated and it will that elongate the that preformer. After that, the basic 1 minute, right? Huh. The basic advantages of stretch blow molding is fast production that you have seen just now, less pressure. Pressure is very less as a core pin is used to stretch the heated preformer, right? Because we are stretching that preformer by the core pin. And what are disadvantages? This process is not suitable for every product. Yes, only the hollow product. Only the hollow product you can manufacture by the blow molding process. Yes, that we know very well. Now, stretch blow molding steps. What are the steps? Injection, right? We are getting a very high quality container frame by using this injection blow molding process. Now, what are the process we are doing here? Injection, stretching and blowing. These things are, simultaneously. These two things are simultaneously. Which one? See, injection is first process. Second thing, stretching and blowing. This is a simultaneous process. And eject the article. Right. After cooling, you have to eject the article. Very simple process. Nothing is there. Only three steps. Now, injection stretch blow molding. This generally I told you it used for the PET. Right, PET bottle, Bisleri bottle. What is the molding temperature? 280 degrees Celsius temperature. And what is the uh, again preheat temperature for the preforma? 100 degrees Celsius. Very simple. This if you keep the two temperature in your mind, you can easily process this type of material frame. Okay, and the pressure is very low required to manufacture this blow molded article. Then first you have to injecting a preforma. First you have to create the preforma, right? That we have created. Reheat. You have seen that we are reheating that by the IR heating element, infrared heating. If it is necessary, yes. If you want to use that after 2 months, then again you have to reheat. But if you are immediately using that, not necessary to reheat, friend. Not necessary to reheat. Okay, and hence, therefore, these are the two variations we have seen just now in the video also. The blowing and stretching of the preforma in the final blow mode. Lastly, thus we are shifting that preforma into the blowing mode, and it will stretch immediately by the core pin, and the article get blown by the compressor here. Now see here, the same system I am showing you by figure. You see extruder here is the preforma mode. Okay. Now you are manufacturer a preforma here. See, preforma is a manufacturer here. Now this preforma, you have to shift. This is a preforma. This one here now. See, here is a thread, and this preforma get heated by the infrared rays, IR rays. After that, this preforma you have to shift here on the blow mode. Okay. Now after shifting, you have to here, this is a blow pin. Blow pin you have to insert here. Blow pin will what it will do? It will stretch stretch this preforma up to here, and then immediately simultaneously the air will be pass here. Okay, it will take the shape of this. देखो अभी shape ले लिया. Now open the mode, you will get the article. Very simple thing. This is the straight injection blow molding process. See now, for more simplicity, you can see this friend. Any question here, friend? Any question? Hello? Hello? Any question here, friend?
No, sir.
We will take a 2 minute break, and then we will again come after
Okay,
2 minutes. Yeah, yeah. See, friend, it's a straight injection molding process. They have shown here in the figure, and it's a very simple figure here. It is a self-indicated figure. It will show you. See, this is a preforma. This is a preforma here. Right. Preforma you can manufacture. I told you, immediate or maybe for 3-4 months also, for 1 year also, nothing will happen to preforma. Okay. But while you want to blow this preforma, then you have to reheat this again. Therefore, you have to again reheat this. Here, the air red heaters are there. Heat this preforma at 100 degrees Celsius because it may be PET one, polyethylene terephthalate sample. Now, see this preforma again, this is now blow mode here, right? Therefore, you have to introduce this preforma into this blow mode and close it. See now, after, see there are two cavities, this cavity and the other cavity is there, but the other cavity they are not shown here. See here, this is a blow pin here. You have to blow this again afterwards. See now here, again this telescopic, this one, again it will pass here inside preforma and it will get elongate. This telescopic core or maybe pin is there. It will just stretch this up to this and immediately it will pass the compressor here, right? So it is joined to the compressor here, compressor here. See now here in this case, same thing happening here now. What I told you just now, see, stretching and blowing. Stretching and blowing by compressor here, take place here. Now, then after cooling, you will get such an article, right? And such article you have to eject. See now here, ejection take place, mode open. Okay. Any question here, friend? Any question? Hello? Any question here?
No, sir.
No. See now, we'll go now ahead. See, now see here. Here immediate process. See now here, no reheating. This is the first version I have shown you just now. This is the first version. See here, preforma made for blow molding and it is kept for 3 months, 2 months, 9 months, 1 year, 2 year like that. When you will get an order, that time you take this, reheat is 100 degrees Celsius and again blow this like this. Now the second method is that direct method. Direct straight injection take place. See now here, preforma is made. Now this preforma is shifted to this blow mode. This is the injection mode for the preforma. Injection mode for the preforma. This is the blow mode for the preforma. So remember these two words, injection and the blowing purpose. This is the blow mode. This is the blow mode for the preforma. So chota hai. Now this preforma injected here, right? Injection mode. It is now preforma form here by injection. Now this preforma you have to shift here. Now see, they are shifted here now. Okay, after shifting, now see the telescopic pin. See now third diagram. Telescopic pin here, stretching this preforma. Okay. Now after stretching, what will happen? It will get stretched and at the same time, see the ear, compressed ear pass from this and it will take the shape of this mode, this internal shape of this mode. And after cooling, you are getting this article. You are again this telescopic spin. You have to remove from this immediately. And mode open, you will get the article. This is a not again reheat that. You are saving time also and also the cost also by inline injection stretch blow molding process, right? Okay, this is a simultaneous process. Just material to direct bottle here. Okay, this middle step, preforma, it is again shifted here immediately. Therefore, no reheating required here in this case. Okay, this is the advantage of this process, friend. Okay, any question here, friend? Any question here? Hello, any question here? Hello, any question here, friend? Now, parallelism programming. Parallelism programming is the control of the wall thickness from top to the bottom of the parison as it emerges from the die head during the extrusion. Parison programming is a must, friend, because you can adjust the thickness where you want. Thin and thick article you can manufacture. From the top you want to thicker article, at the bottom also you want to thicker article. Okay, and at the middle you can use the thin also, it will work there. Therefore, for example, Bisleri bottle or maybe drinking water bottle or disposable bottle, they are manufacturing by this way. Therefore, here parallelism programming nowadays you can save the material and many things. Okay, use this parallelism programming to get the accurate and quality product. Now, by electronic Parisian programming, we can also show you the orifice modulation method in which the die is fitted with the hydraulic positioner that allow positioning of the inside diameter during the Parisian drop. The OD outer diameter to inner diameter relationship of the tapered die orifice opening is worse in a programmed manner to increase or decrease the Parisian wall thickness. Very simple. See, friends, this is a electronic Parisian programming. You can change the thickness at various places. Okay. Now, what is meant by Parisian swell? Parisian swell means what? After leasing the die, therefore, after leaving the die, the mate which has been under the shear pressure undergo relaxation process, and that causes cross-sectional deformation or swell, which is called as a Parisian swell. See, why the Parisian swell occur? With the material passing through the die, they are under the pressure, and therefore when it get exist, जब बाहर आता है, it go to undergoes relaxation because the polymer have a memory, plastic have a memory that go to under relaxation, and that causes a cross-sectional deformation of the that material or Parisian, and it swell. It is called as a Parisian swell. See now, Parisian programming. See, we can do here, see the thickness here, we want higher. See here, at the shoulder, we want higher thickness. See here, 0.90 inch. Here, 0.70 inch. At the neck. See now at the middle here, 0.066. Therefore, you can save the material here. Again, it is a completely lower here. Thickness is very low. See this side, 31, 31, 31. Here 27. Okay, 52 here. It's another bottle. See now here again, here is a 1. Thickness is a 1 here. See, 1 millimeter. Higher here in this case. Okay, at the bottom line. So friend, see this is a Parison programming means you have to adjust the thickness of the bottle at various places, neck, shoulder, middle, above the bottom and bottom. Are you getting me? Hello? Hello, am I audible?
Yes, sir, we are getting.
Yeah. Therefore, friend, how the you can save the material, how can you save the thickness, right? How you make the good article, right? See the thickness here, thickness they have given here, shown here. Bottom, higher thickness, neck, see the thickness here, middle, very low thickness, lower thickness. And therefore, this indicate that you are getting a dimensionally stable material product, and this wall thickness variation in Parisian can be controlled by the Parisian programming. This is available in the machine itself, right? Thus you have to adjust the parameters. बस ये parameter डाल दो उधर, neck, bottom, shoulder, ये middle one, upper top, lower top, uh, and bottom, upper bottom, lower bottom. Then you will get. Now this is actually Parisian programming, right? Now here, if you see this a mandrel here, program Parisian showing here heavier wall thickness for greatest expansion area. See now here, it's very heavier. While the mold, filling, the time see this is a here it show the more area here. Okay, cooling cavity. See the cooling take place here from the outside of the mold. Now see here how this thing happened. See, this is a die here, and this is a pin here. Okay, or mandrel. Now see this mandrel and die. See, this mandrel is same position. Here die moment is there. This is a die. See, now die is here going up. Here die is coming down. When the die coming down, the diameter goes on decrease. See, the die goes on this side. See the diameter here. See the thickness of the Parisian. See, when it is going outside, when it go above die, and you see this is the stationary. Mandrel is stationary. Die move up. Therefore, here is a die swell, and see the thickness, lower thickness. But see now here, see the thickness here, higher thickness. When the die coming down, see the gap between the increase, and see here the higher thickness of the article. So thickness higher here, thickness is lower, and this is done by thus die moment, die and कभी कभी die stationary pin moment stationary, then die moment. See, in this above case, here the die moment is there, going up and down, die going up and down. Here in this case, now see now, pin here now, pin going up and down now. See now here, pin is at the place, see the diameter here. See the here diameter of the Parisian is lower here. But see now, as this pin go up, थोड़ा सा तो इधर distance बढ़ गया. This distance will increase. Therefore, thickness of the Parisian will increase. Therefore, thickness, the wall thickness of the Parisian can be controlled by two methods. One is die stationary, pin go up and downward. Then pin stationary, die go up and down. See, this is a very unique process frame to control the thickness of the Parisian. Thickness of the Parisian. See now here, same thing. How they control now? The gap here increase. Right? See the gap. When this pin is coming downward direction. See now here also. Same thing they are showing here now with a different type of a moment. This is called as a preforma. See now, this is a preforma, friend. Right? Maybe any color. And this preforma you can store maybe 1 month, 2 month, 3 month, 1 year, 2 year, 3 year, nothing will happen. But when you want to take the blow, when you want to make a bottle of this, then again you want to reheat this at 100 degrees Celsius temperature. Therefore, friend, Parisian is the part of is used by blow molding, where air is inflated to form the desired shape. It is a one end closed test tube, right? Preforma. The preforma is same as Parisian, but there is a thread in the open end in the preforma. See, here is the open end. Threads are there. Okay. वैसा parison के इधर there are no thread. Remember this thing. Preforma having a thread, but parison don't have thread. Remember this thing. Okay. Therefore, preforma is mostly used in a bottle. To manufacture the bottle, we are using the this type of a preforma. PET, PVC. Okay, these are the generally material used to manufacture the bottles. Okay. Any question here, friend? Any question here? Now, see the average Parisian swell for new commodity plastics. See now, SDP कितना swell होता है वो? First 15, then 40%. Then SDP 25 or 65. LDP 30 and 65. See here, कितना die swelling. PVC 30, then 35. Polystyrene 10 and 20. Polycarbonate 5 and 10%. This is the swelling, right, of the Parisian of the commodity plastics. Now you can see this Parisian programming a video. Then you will get idea how the Parisian thickness of the uh, ball it get controlled. Hello, am I audible? Hello, am I audible? Hello, am I audible, Praveen?
Yes, sir, you are audible.
Yeah, yeah. Now see this video so that you will get a complete Parisian programming. See now here thickness, how the thickness is there. See. Friend, there are two types, convergent die and the divergent die. Okay. Now see in this case, here that they are given a four figure and you can adjust this a die type, right? You can take this bush up and down. Pin is at the original place, stationary. See now here also, the pin is stationary to take the bush up and down. But see in this case, here you are just pushing this, the mandrel or pin upward and downward. See here, in a convergent die also, this is a convergent die. This is a divergent die. This is again a divergent die. This is a convergent die. Therefore, friend, you can push up and down, right, as per your, the need. Okay. And you can combine this and you will get a complete a quality picture of that. Just listen again. This is a very interesting, friend. See, these are the advantages of the, what is the programming? Cooling time less, watt thickness, distribution is very good, and reduce the amount of plastics. Therefore, it is an economical one. We can save the material, right? Therefore, we can save the price. We can, make the article with the optimum properties. Okay, by this way. This diameter and parallel thickness. See now here. So friend, we can increase the diameter of the bottle or we can decrease the diameter of the bottle. We can also increase the thickness of the bottle and decrease the thickness of the bottle by using only the Parism programming process. Okay, this is the only, the advantage of this. Now, there are two type dyes, diverging and converging dye. Therefore, you will get thin article. Okay, thick and thin article. Yes. Yes, therefore, it's a thin article. Therefore, you will get the higher thickness here, higher thickness. Therefore, friend, see, Parism program is a very important part of this lecture, and you should know this Parism programming. because of convergent die and divergent die. You have seen that, and this is the moment of the mandrel and the bushing. If the bushing is stationary, the mandrel will go up and down, so that you whatever the thickness and diameter you want, you can get. Okay, by using this divergent die. Even you can use it convergent die. There is also a bushing. Just there's a pin or mandrel. Just pin is stationary. That the bushing is movement. Right. Now you can do the movement of the bushing up and down, so that you will get the diameter increase, diameter decrease, or thickness increase or thickness decrease as per your requirement. See now here there are two type of die here. Now this is a torpedo die. Okay, this is again a pin die. See now here is a central die. See the side fed die or center fed die. This is called as a center fed die. This is called as a side fed die. Now friends, see here difference how this will help you. See now here the material coming through this is here is a extruder. Here is a breaker plate, screen packs are there, and the material get fall here from the top on this mandrel. This is a torpedo. This torpedo is a highly finished, mirror finish, completely chromium plated. Okay. Now, due to this highly finished torpedo is here, the material fall here, made molten mass fall here, and it will get spread immediately. See now, completely immediately, because of see the material not going to wait here. It will not going to wait here, stagnant here. Okay, and see now here the material get diverted this side and diverted this side, and all 360 angle, and then you will get here the parison by using this torpedo. Now, see in this case now, this is a called as a side fed die. There is a extruder, breaker plate, screen packs, and the die is here. See now, here the from the side, material going to this a die, and this is a mandrel here. Material gets spread here. Okay, it will take a time to spread this material. The die is heated here, friend, and therefore such a die, side fed die, are used for a heat stable material, polyethylene, SDP, polypropylene, like that. But if you see, this type of die is used for a PVC material, PVC and PET, right? Polyethylene terephthalate, polyvinyl chloride, because these are the sensitive material, polycarbonate, that sensitive material. Therefore, direct, immediate, there is a no residential time here. Okay, here is the residential time higher. Here is the residential time very lower, because directly you are falling the material at the torpedo, and it immediately come down. But here it is not like that. Material going through this die, this is the land is here, and this gets spread here. It will take a time, and therefore this is a use for the heat stable material. Okay, for SDP, polyethylene, polypropylene, like that. Any question here, friend? Any question here? This is a center fed die. This is a side fed die for the blow molding purpose. Now you just see this video so that again you will get a clarity on this. A See, preforma, they see preforma they have made now. Okay. Now again is the condition take place now here, conditioning. And now it is going to the blowing station now. See now. It is just turn now and it goes to the blowing station. Therefore, a 15, bottles, see now here. The stretching and blowing take place immediately here. See, this is a blow mode. See, this is a bigger bottle. Okay. Now see what is going to happen now. See now. Yes. Stretching and blowing take place immediately. Okay. And now you can remove the. Now it is a now cool now. The article get form here. Now it is a now mode open. Now you are getting the bottles here. See now on the conveyor belt. There may be a 15 or 20 bottles simultaneously you are getting in the one shot. Okay. See, this is a machine. See, now again injection take place. Now conditioning take happening. Now this is going to where now? It is going to the, yes, blowing station. Now see the pin will act. Directly compressor will act. And it will take the shape of the blow mode. And then you will get the a 15 bottle immediate. See, these are the bottles manufactured by this injection stretch blow molding machine. See, PET, PPC, PP, polyamide, polyethylene sulfate, all acrylic also, this HIPS, polystyrene, these all material are used for the blow molding purpose. The frame, now we will see the now injection blow molding. Now we have completed stretch blow molding. Now we will talk about the extrusion stretch blow molding. See, extrusion stretch blow molding is suitable for PVC and PET. Injection stretch blow molding only suitable for PET. But now see here, a injection blow molding are suitable for both PVC as well as a PET material. Now, what are the process? The say shooting the Parisian, yes, converting the Parisian into the preform and blowing and stretching the preform into the final mode. Very simple process, like injection molding process. But here, again, you have to create the Parisian into the preform form. See now, I have one video. You can see this video how they are, converting and how the extrusion take place. You can see this. It's a industrial stretch blow molding frame. See again, preheating, conditioning. This is a blow mold now. And blow molded. Simple principle. With the jerry can now. See here how the material get mixed together. Color mixing. Is pouring the material now. There may be some recycled material. And see how the jerry can are manufactured. See now here. See, this is a mold. This is a very simple, this type of is also manually is also available now in the market. But it required too much, effort, friend. Lot of, work you have to do there. See this is now a Parisian. See now, now blowing take place. Now use now cutting the pinch, right? Flashes. Now see now how we cut the flashes. See now. This also work you have to do the manually, but in automatic machine, these things are happening automatically. Just purposely, I am showing this video how the things are trimming after the formation of a drum or maybe any type of a blow molded pot. The jerry can manufacturing plant, friend. See now again, this is again extrusion blow molding process. See, this is I told you, extrusion blow molding. See the big container we are, or maybe can, we are manufacturing by extrusion blow molding process only, friend. See now, very big article, a big drum, you are manufacturer. See now here. The bottom is a pinch off, right? He has to cut that first pinch off. And see now, even he will cut the flesh. See now, how this thing happening from the below, that they extending that because of the you want to handle. Now see now it is a cut now by the blade. You can see again this, because it's a very unique video frame. Jerry can manufacturing. Am I audible to you, friend? Hello? Hello? Am I audible?
Yes, sir.
Yeah. Just see this, how the handle is manufactured. See how this, this is a very big container they are manufacturing. And they have to, remove the flash also. See now, see the bottom. Now is extending there and then cutting that. Pinch off. That is called as a pinch off at the bottom. See now it is a cutting at the top. But it's then it cut at the top now by the blade. Now, see, friend, see the design of this bottle. Just now we have seen here. See, this is a handle wala bottle, right? How it is a manufacture. At the bottom, you just extend that this part, and you can close the mode. You will get such a type of article. See now, this is a wastage of material now here. Handle ka jo line crossing line, there is wastage of material. Therefore, friend, here a blow pin is there, and the assembly screws are there. Then thread insert, you have to add the insert here first at the neck of the bottle. Then there the dowel pins are there. Then main body selection pinch off. Here is also a pinch off at the side of the bottle. Then this is a relief area of a pinch off is 8 millimeter deep each half and 0.5 millimeter land. See now here, right? Bottom insert section, the bottom insert section a frame that is called as a pinch off. Okay, it's a design actually, frame of the mode. See now here again, you can see here, this is the temperature control, cooling line 1, 2, 3, 4. Right, these are the cooling line you can see here, friend. See 1, 2, 3, 4 cooling line. Water go in and out. Is a year, right? We can pass the year here. Then see the shrinking plane mode section. This is a mode section here. Pinch off is at the bottom. Then is a calibration blow. This is a blow pin here. This is a blow pin here, right? It is a deflasting sleeve is there, right? See, this is the design. Now see now here, this is a pinch up here, and you can insert here bottom, right? If you want to insert anything, you can insert. Here is the ear entrance. See, it's by the blow pin. It's a stretch blow pin here. You extend up to this, up to the bottom, and immediately the compress here will pass and it will take the shape of this mode. This is all the cooling. Cooling of the neck is very important because it's thicker here. जहाँ जहाँ thick है section, उधर आपको you have to place the cooling there. Now stretch blow molding process characteristics. If you see the PET, use temperature 250, PVC 199, pan 210, PP 168. This is the processing temperature, made temperature. See now here, stretch orientation temperature. You have to again for the orientation preforma. Now you are preparing first. Then for reheating purpose, see these are the temperature: 88 to 116, 99 to 116, 104 to 124, and 120 to 136. And maximum stretch is possible in case of the PET. We can stretch at any level. Okay, stretch is higher in case of a PET. See now here is a blow pin going, it gets extend to this periforma up to this place. See now here, and immediately the air will pass here. It will get blown. Therefore, friend, factor to consider when reviewing the complete unit, part design is very important. Material, which type of material, their chemical structure, MFI, mold design are very important there. Machine capability also very important, and molding cycle that you have to keep in mind. These are the temperature for blow molding purpose. See, LDP, you have to mold temperature, molding temperature are 130 to 180. These are all for the number of polymer and their melting temperature here. Then pressure. If you in a blow molding, how much air pressure will be there, right? Blowing pressure. Acetal, see, require 100 to 150. PVC require temperature 75 to the pressure 75 to 100. See, these are the pressure to pass the air for the blowing purpose. Now, factor affecting the blowing molding, the Parisian characteristics: size, shape, straightness, wall thickness, mechanical strength, inflation also. Process pressure will be set according to the process. Stretch blow molding pressure is less needed. I told you because we want very low pressure there. Then mold design is very important, right? Blow ratio, mold diameter divided by the Parisian diameter. It's called as a blow ratio, right? Therefore, Parisian may be, at the bottom, it may be swell, right? These are the very important things. That's called as a blow ratio. Now, blow molding application, milk bottle, pharmaceuticals, air freeze bottles, garbage, drums, fuel tanks, and ice chest and coolers. Now, friend, blow mold design parameters. How can you design the blow mold? The selection of a proper plastics is very important because some have a higher viscosity MFI, some have a lower MFI. Viscosity is higher, viscosity is lower. Then appearance of the product. See, here we are using only the blow molded article, not the solid articles. Remember this thing. End use property, what type of property you want after falling from the height, that also you have to think about that. And cost economy. If cost economy, it is a benefited, then we will go for this. Otherwise, we can't go for this process. Now, stretch blowing. See, the maximum wall thickness for preforma is 1.5 mm. Okay. And minimum wall thickness should be 0.35. Then and then we can do this stretch blow molding. Otherwise, no. Keep in mind. Somebody giving you less than this size, it is not possible. Therefore, while you buying the preforma, you have to check up this first. Wall thickness of the preforma. Now, see the mode cooling lines, how you cool the mode. This is a blow mode. we are providing the cooling section here, out and in. See, water is going inside here. It get cool completely here around the 360 degree and then coming out this water. Okay, this is a mold cavity here. The pinch off as the bottom. If you thread insert, you can insert here threaded because generally thread is not available with the mold. Okay, therefore you have to insert this thread here with the mold. Okay, this is the back pattern here, friend. See, the cooling, how much distance will be there? See, this is a P here, the distance, pitch. Okay, it is a 3D to 5D. Remember this thing, diameter of this a cooling hole or drill. Therefore, distance between these two drill, there should be 3D to 5D distance should be there. This is the criteria to supply the cooling water inside the blow mode or blow cavity, right? Because it is a both are cavities there. Okay. Then depth of the water line. See, this is the depth of the water line here, right? P is the pitch and diameter of the water line. D is the diameter of the water line. See now here. जितना यहाँ इतना water हम छोड़ते हैं अंदर. It's a diameter to pass the water inside. Okay. This is a depth. Okay. And now diameter of the water line is this much. Okay, diameter. Here, this is a diameter. Okay. Now, blow mold cooling consideration. The type of plastic being molded, right? Which type of plastic you want to mold? So that we can address the mold temperature. What thickness of the molded part? How much thickness? If the thickness is higher, that place you have to pass the higher cooling. Then type of mold material used to construct the mold. What is MOC of the mold? Mold wall thickness between the cooling channel and the cavity. These are very important. Temperature of the cooling water. Volume of the mold cooling water. How much volume you are using? Design of mold cooling water zone. Blow air pressure that we have seen just now. And surface roughness of the mold cavity. These are the materials. Aluminum alloy. Right. These are generally used for as the aircraft grade aluminum, which contains zinc, magnesium, copper, and which will, useful for us to pass the temperature, conductivity, right? Machinability, lightweight. Then beryllium copper. This is also alloy used to manufacture the blow mold, right? The steel. There are also some mold for PVC, right? We are using the steel mold, right? Because of without corrosion, and it is a extremely toughness. And also the surface finish is very good for the stainless steel material. And it is also acquired by the etching process from the steel, right? You can do the highly surface finish of the steel by etching process. And then miscellaneous material, zinc alloy, right? This is also available in the market nowadays for the MOC for the blow mold. Blow mold design bottle, the shapes require a material to be blown, right? Which material? Size and weight of the product. Counter to on the part कैसा है? Round है कैसा है? Surface texture and young graving, right? On the surface inside. Then sharp corners and straight edges. These are the very important, friend. Blow opening available at the location and parting line, right? Blow pin, top blowing, side blowing, bottom blowing, parting lines 1 or 2 that also affect the mold design. Then material properties for the blow molding, good thermal stability, right? Thermal stability should be very good, otherwise cooling will not effective. Then good flowability of the homogeneous melt, sufficient stretchability of Parisian, excellent repeatability of the Parisian weight and the length, smooth Parisian surface. Remember this thing. Compatibility with the additives of the material. If it is not compatible, then again there will lamination will form. Therefore, you have to take care of the compatibility of the additives. Sufficient wide processing range. Temperature is very important. Friend, these things are very important for selecting the material for the blow molding. See now here, MFI, melt flow index. See, we want here, remember this thing, it's a very, 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 very important thing. Melt flow index for blow molding require 1 to 2 only per 10 minutes. See, highly viscous LDP, then highly viscous LLDP, 1 to 2 only. SDP, 1 to 2 only. Therefore, 2 gram per 10 minutes, not more than that. Such a material we are using for the blow molding purpose. Remember this thing. Therefore, highly molecular weight require, higher molecular weight require. Therefore, you will get a higher melt strength. This indicate a higher melt strength here, friend. Okay. Are you getting me? Hello? Hello? Are you getting me, friend? Hello, Praveen? Hello?
Yes, sir, we are
Ha,
getting.
ha. See the MFI required for this blow molding purpose. Very less. Because this we want a viscous material for blow molding. Remember this thing. We cannot use this material for injection molding. See, remember this thing. We want a special grade for the blow molding. Remember this thing. Injection molding, we want a higher MFI. But here we want a lowest MFI. 1 to 2 per 10 minutes. See, anybody will ask you where the MFI require higher. Right. MFI we want for injection molding purpose. But for blow molding purpose, very low MFI. 1 to 2. Remember this thing. Now, friend, concentration of bottle design. But these are the vertical strength, wall thickness, push-up strength, labor consideration, all things you have to keep in mind while designing the mold for the blow mold purpose. Okay. Now, friend, we will finish here. We will see the troubleshooting tomorrow of the blow molding process, and then we will start the calendaring plant, right? Tomorrow. We will meet tomorrow uh, by how the calendaring sheet is manufactured, how film is manufactured, what are the calendars, types of calendar, drive system of the calendars, how the plant is their friend, and many things we are going to see, even video also and the information also. We will meet tomorrow at 6:30. Okay.
Tomorrow is holiday, Christmas.
But our lectures are there, friend. Hello.
Sir, our office is closed. Sandeep Shinde.
Huh?
Our office is closed.
अच्छा, okay, okay. So tomorrow
Ah.
is, oh, अरे sir जी. अच्छा, okay. अच्छा, okay. Then friend, we will meet, day after tomorrow.
Yeah,
Okay.
please. Sorry
Yeah,
for
yeah.
late
Okay,
coming.
sir.
Yes,
Okay.
yes. Day
Thank
after
you.
tomorrow. Yeah. Okay. Have a good night, friend.
Good
Sandeep
night,
sir.
sir. Yeah, good night, sir. Good night.
Thank
Good
you,
night,
sir.
sir. Thank you.
Good night. Good night.